Hello friends, welcome to CEC live lectures. Friends, in this session today we are going to study about the fundamentals of Boolean logics and gates, and for the discussion on the topic we have with us in our studios Dr. Mansaf Alam. Dr. Mansaf Alam is Associate Professor in Department of Computer Science, Jamia Millia Islamia. Friends, Dr. Mansaf Alam has immense experience, and we believe that through his experiences we are going to get in-depth knowledge on today's topic. Friends, if you wish to ask questions from Dr. Mansaf Alam, then do call us through our toll-free number. Our number is 1800110430. I repeat, our number is 1800110430. Now, I would like to request our guest, Dr. Mansaf Alam, to give us in-depth knowledge on today's topic. Hello, sir. Welcome to the lecture.
Hello, friend. Thank you, ma'am, for giving me opportunity to give a lecture. I am Dr. Mansaf Alam from Department of Computer Science, Jamia Millia Islamia. Today I will teach you fundamentals of Boolean logic and gates. What is the role of logic and gates in computer science? Fundamental gates will be taught in this session. Let us start. Boolean logic. It is defined as a type of decision making used by computer to decide whether a statement is true or false. So, the type of Boolean operator, the four main Boolean operators are used to evaluate whether a statement is true or false. These operators are given below. AND operator. The result is true if both operands are true. OR operator. The result is true if at least one operand is true. XOR, the result is true if only one operand is true. So, negation operator, the result is true if a single operand is false. Let us consider two variables A and B and apply all the fundamentals operator on A and B. So, here A and B, first consider A is false, B is false, then apply AND operator A and B, then the result will be false. On the same status, A is false, B is false, then in the case of OR operator A or B, there will be false. In case of XOR, both A and B are false, then X or B will be false. In the case of negations, A is false, so not A is true. If B is false, not B is true. Let us consider another case. A is false, B is true. Then you are applying AND operator. In that case, result is false. And in case of OR, result will be true. If any one input is true, then the result will be true in the case of OR operator. And same statement false, true. In the case of X or B, the result is true. In the case of NOT, on the same status, A NOT means A is false, then the result is true. B is true, then B NOT is false. Now consider next state. A is true, B is false. Then in the case of AND operator, result is false. In case of OR, result is true. In case of X or B, result is true. And in case of not A, so A is true, then B is false. And B is false, then B not is true. Now consider another case. Both the input are true. A is true and B is true. In that case, you are applying AND gate, then the result will be true. In other case, suppose you are going to apply OR operator on A and B, and the input is true and true, so the result will be definitely true. In case of XOR, both input true, then the result is true. And if A is true and not, again the false, B is true, then not B is false. So now that table can be converted into the 0, 1. So if you replace true with 1 and false with 0, in that case the previous slide table is converted to like this type of table A, B, 0, 0. In case of 0, 0, if you are applying AND operator, the result is 0, that is indicated in the red, and if A and B is 0 and applying OR operator, then A or B is 0, and if we are applying XOR on A and B while A is 0, B is 0, then the result is 0. In case of NOT, A 0 means NOT is 1, B is 0, applying NOT operator, then 1. Another case, another step 0, 1, A is 0 and B is 1. So if we apply AND operator, then the result is 0, and if we apply OR on input 0, 1, result is 1, and if applying XOR, then the result is 1, and same in the case of NOT, A is 0, then A dash or A naught is 1, B is 1 here, then B naught is 0. Next A is 1 and B is 0, and if we apply A and B, then the result is 0. If any one result is false, then definitely the result will be false. And if we apply OR operator on A and B while A is 1 and B is 0, then the result is 1. Why it 1? Because any one input is 1, the result is 1 because it is true. And the same case, applying XOR, then result will be 1, and same in the NOT case, if A is 1, then NOT is 0, B is 0, then NOT be 1. Now consider both the input are 1, 1. So if both input are 1, 1, then applying AND operator, then that will be the 1. In case of OR, both input are 1, 1, then result is 1. In case of XOR, result is 1, and in the case of NOT, if A is 1, then NOT is 0. Here in this case A is 1, then the result is 0. In the case of B is 1, again result is 0 in the case of NOT B. Now here a mathematical concept, power set, is also used. Let us understand what is power set. So the power set is defined as a set of all the subset of set. Let's consider a set X equal to X1, X2, X3 and X4. So all subset of set X are X1, X2, X3, X4, comma X1, X2 altogether, X1, X3, X1, X4, X2, X3, X2, X4, X3, X4 and X1, X2, X3, X4. All are the subset of the set X. So X1, X2, X3, X4 set is also the subset of set X equal to X1, X2, X3 and X4, but it is not a proper subset. And an empty set, double bracket, curly bracket, is also a subset of X set. If you are listing all subset of X sets, that all sets will be the power set of X set. The power set is denoted by P in bracket X. The power set Px equal to curly bracket and double curly bracket, comma, X1 in curly bracket, X2, X3, X4 and X1, X2, X1, X3, X1, X4, X2, X3, X2, X4, X3, X4, X1, X2, X3 and X4. So these all are the power set. Let us see one example of power set. Let us consider if the set X is defined as set X equal to X1, X2, X3 and X4. Now find the total elements of power set. So let us first understand notation of power set. The number of element of a set defined mod x, where x is the name of set. The power set is defined as mod px equal to 2 to the power n. So in the given example, the elements of x is 4. So the element of x are 4. So the total elements of power set are 2 to the power 4. So you can expand it and make the computations. So that will be 2 into 2 into 2 into 2, that is equal to 16. So 16 is the power set of the given set. Let us consider another example. Y is defined as y equal to set 1, 2, 3. What are the total element of power set? Solution. Here y having 3 elements, therefore total number of elements in the power set are py mod equal to 2 to the power 3, that is equal to 2 into 2 into 2, that is equal to 8. Now let us understand what is Boolean algebra. So Boolean algebra deals with 2 or more variables which value is true or false, you can say 0 or 1, and functions that find its use in digital computers. The two states true or false is used in binary system. George Boole is a mathematician who gave the concept of Boolean algebra. He used 1 for true, 0 for false, dot for and plus for or. So consider the statement, I will appear in a test if I have a pen or I have a pencil. This statement shows that facts that the proposition appear in a test depends on two other prepositions, have a pen and have a pencil. Any one of these two compositions can be either true or false, hence the table of all possible situations is given below. The two operators are defined as OR operator represented by plus and AND operator represented by dot, that is also known as the dot operator. The NOT operator is the third operator in Boolean algebra which inverts the input. Suppose if you have input is 1, then after inversion it will be 0. 1 may be 0, 0 may 1 in the case of NOT. So the next slide table give for the above situation. Let us see here situations. You have two components, pen and the pencil, and appear in the test. If you have a pen, so whether you are going to appear in the test or not. If you have a pencil, whether you are going to appear in the test, whether you have both pen and pencil. So let us see the situation. Pen, no. Pencil, no. Appear in the test, no. Another situation, pen, no. Pencil, yes. Then you can appear in the test. Another case, pen, yes. Pencil, no. Then in that case appear in test, yes. And both case, pen, yes, and pencil, yes, then you can definitely appear in the test. Now this table can be converted into the another form, in the form of 0, 1, which computer can understand. Let A equal to pen and B equal to pencil. So S equal to 1, no equal to 0, and X equal to appear in test. The table can be represented in binary system as below. You have two variables A and B. So write down first all combinations A, B, 0, 0, 0, 1, 1, 0, 1, 1. If both A and B are 0, then result is 0. If A is 0, B is 1, then the result is 1. If A is 1, B is 0, then the result is 1. If A is 1, B is 1, then the result is 1. So, above table converted into the binary form. So, the three operators are the basic operators used in Boolean algebra, and from which more complicated Boolean expression may be written. The Boolean expression from second table in the previous slide is written as x equal to 1a dot b dash plus a dash dot b plus a dot b. Now, let us see postulate. The postulate is defined as something taken as self-evident or assumed without proof as a basis for reasoning. In mathematics logic, a proposition that required no proof, being self-evident or that is for a specific purpose assumed true, and the postulate is generally used in the proof of other propositions. Axioms postulate is universally accepted. Let us see one example. 4 into 3, that is equal to 3 into 4 is the same thing. Either you can write 4 into 3 or 3 into 4, that is universally accepted. There is no need to prove this fact. Assume A, B and C are logical states that can have the value 0 false and 1 true, plus means or means and not A means not A. So, dot is used for and plus is used for or. Now, here are some list of postulate. First postulate, identity postulate, means A plus 0 equal to A for all A belong to X, means all A elements are the elements of A is the element of X, means A belongs to X. Complement postulate, A plus A dash equal to 1 and A dot A dash equal to 0. Next postulate, commutative law, A plus B equal to B plus A and A dot B equal to B dot A. Associative law, A plus within bracket B plus C equal to within bracket A plus B plus C. Distributive law, A plus within bracket B dot C equal to within bracket A plus B dot within bracket A plus C and A dot within bracket B plus C equal to within bracket A dot B plus within bracket A dot C. Now, let us see theorem. How can you define the theorem? So, according to mathematics, the theorem may be defined as proposition that has been or is to be proved on the basis of explicit assumption. List of theorems of Boolean algebra. Theorem number 1, A plus 0 equal to A, where A equal to 0 and 1. Next theorem, A dot 1 equal to A, where A equal to 0, 1. Next theorem, A plus 1 equal to 1, where A equal to 0, 1, means all variable defined on 0 and 1. So, next theorem, A dot 0 equal to 0, where A equal to 0 comma 1. Next theorem, A plus A equal to A, where A equal to 0 comma 1. Next A dot A equal to A, where A equal to 0 comma 1. A complement to the complement A equal to A. Complement of a complement is a original variable where A equal to 0, 1. A plus A dash equal to 1 where A equal to 0, 1 means all the cases the value of A will be 0, 1 either true or false. Another theorem, A dot A dash equal to 0, A plus AB equal to A. Next A into A plus B is again A plus B dash into B equal to AB, AB dash plus B equal to A plus B, A plus B plus C plus D dash dash equal to A dash dot B dash dot C dash dot dash up to N. This law is known as Demarcus Law defined on plus operator. And another Demarcus Law defined on dot operator A dot B dot C equal to A dash plus B dash plus C dash plus D dash dash dash. This Demarcus Law defined on dot operator. And the next theorem, A plus B within bracket dot within bracket A dash plus C equal to A dot C plus A dash dot B. And next theorem, AB plus A dash C equal to within bracket A plus C and dot within bracket A dash plus B. So previous slide discuss about the theorem and the postulate. Now let us see what is Boolean function. So Boolean function is defined as a function into the form of f colon n tends to A, where A equal to a set of false or true is defined as Boolean domain and n is a positive integer. In the case where n equal to 0, then f is called the constant function and its value become constant element of A. The Boolean domain has been seen in the field of logic as A equal to 1, 0, where 1 stands for true and 0 stands for false. It is found from count of Boolean function. There are 2 to the power 2 to the power n Boolean function on n variable. This formula is used to count the Boolean function. Example, how many Boolean functions are from 4 variables for the count of Boolean functions? Let us see the solution. We know the number of Boolean function equal to 2 to the power 2 to the power n, where n is a variable. Here the value of n is 4, so the number of Boolean function is 4 to the power 2 to the power 2, that is equal to 2 to the power 2 into 2 into 2 into 2, that is equal to 2 to the power 16. So the 2 to the power 16 can be written as 2 to the power 10 into 2 to the power 6, because base are same. So 10 plus 6 is equal to 16. So we know 2 to the power 10 is equal to 1024 and 2 to the power 6 is equal to 64. So 1024 multiplied by 64, that is equal to 65536. The Boolean function is defined in another way by introducing the dependent variable and independent variable. Let A and B are independent variable and Y is dependent variable. The relationship between independent variable and the dependent variable is given as follows: y equal to summation a comma b और y equal to pi यानी कि productions a comma b. If value a and b are known, then we can find the value of y. This relationship can be represented like here some function in represented in the sum of product. If a equal to a set of 0, 1 and b is again the set of 0 and 1, then find the cross product of a and b. A cross b, that is equal to curly bracket in a bracket 0 0 comma 0 1 comma 1 0 comma 1 1. So this is the cross product of a and b. The function in product of sum can be written as if within bracket a comma b equal to summation curly bracket within bracket 0 comma 0 comma 0 comma 0 within bracket comma 1 comma 0 within bracket comma 1 comma 1 within bracket and curly bracket close. So that is equal to 0 0 plus 0 1 plus 1 0 plus 1 1. In this equation, the first digit represents a and the second digit represents b. Replace first digit with a and second digit with b. 1 with normal variable and 0 with complement variable. The equation f comma b in above slide can be written as f a comma b equal to a dash b dash plus a dash b plus a b dash plus a b. This function can be represented in product of sum as f a comma b equal to pi यानी कि productions 0 comma 0 comma 0 comma 1 comma 1 comma 0 comma 1 comma 1. So that can be written in product of sum 0 plus 0 into 0 plus 1 into 1 plus 0 plus 1 into 1. So finally we get the function f a comma b equal to a plus b into a plus b dash into a dash plus b into a dash plus b. So we can continue it after a break. Thank you.
Thank you, sir. Thank you so very much for giving us a productive session where we learned a lot about Boolean logics and gates. And friends, we will be back after a short break and we'll be discussing more. So be with us. Thank you. Hello friends, welcome back to this session where we are discussing on fundamentals of Boolean logic and gates, and we believe that you might have learned a lot through our previous session. So friends, in this session also we are going to discover a lot through Dr. Mansaf Alam, who is our today's expert. If you wish to ask questions from Dr. Mansaf Alam, do call us through our toll-free number. Our number is 1800110430. Now I would like to welcome our guest Dr. Mansaf Alam once again and would request him to explain the other elements of Boolean logic and gates in detail. Hello sir, welcome to the lecture.
Welcome back friends. Let us now see one example of the previous slide. Example is here, write the truth table of the function f a comma b equal to a dash b dash plus a dash b plus a dot b dash plus a dot b. So you can write down the truth table of any given functions. You can learn this how to write the truth table of any given function. So let us see here. There are two variables a and b. First write down all the combinations of a and b. So all combination of a b is 0 0, 0 1, 1 0 and 1 1. Put the value of a and b in the given equations and perform the computations, get the result of expression. That will be the final result in the table. Let us see the table. A and b are 0 0. So function put the value of a 0 and b 0 in the above expression a dash dot b dash plus a dash dot b plus a dot b dash plus a dot b. Let us see explanations. A is 0, so complement A is 1. So in the explanation 1 dot b is 0 and complement of b is 1, so 1 dot 1 plus next term a is 0 and complement a is 1 and the b is 0, so put b 0, so 1 dot 0 plus for the next term a dot b dash, so a is 0, put a 0 dot b dash, so b is 0, the b dash is 1, so 0 dot 1 and the last term a dot b, a is 0, put 0, b is 0, put 0. So now you can 1 dot 1 is equal to 1, 1 dot 0 equal to 0 and 0 dot 1 equal to 0, 0 dot 0. So 1 plus 0 plus 0 plus 0, the summation is equal to 1. So you can write 1 in the function. Now consider the different combinations of a and b. A is 0 and b is 1. Again put the value of a and b in the expressions, and after putting these all value and evaluating the expression in the explanations will get 1, so put 1 in the function column. Now consider value of a and b is 1 0, value of a is 1 and value of b is 0. Now put the value of a and b in the above expression a dash dot b dash plus a dash dot b plus a dot b dash plus a dot v. After putting the value will get the result 1 and put this 1 in the function. Similarly you can put again the combination a equal to 1 and b equal to 1 in the given function, and after evaluating the expression will get 1. So in this way you can write the truth table for any given function. Now consider another example. Find the Boolean function for f1 and f2 from the given truth table. So in the table there are 3 variables x, y, z, and the all combinations are 8. So in a question the table is given. From the table we have to find the Boolean function. So first you can scan the given function output. F1 and F2 are the output, x1, yx, yz are the input. So first you have to find the function for F1 and the F2. So first scan F1 from top to bottom. If 1 is encountered, then write the corresponding variables in the term and sum all the terms to get the function in sum of product. So let us see in the given table at x0, y0, z0 and f1 is 1. So you have to consider this term, this row. Another one at x0, y1 and z0 is 1. So you have to consider this row. And next one at x1, y0, z0 is 1. So you have to consider this row. And next one at x equal to 1, y equal to 1, z equal to 0, and at the last x is 1, y is 1, z is 1. So, where 1 is available in the function, that can be considered. So, f1 x comma y comma z is equal to, in the first row 1, so x is 0, so you can put x dash, y is 0, so you can put y dash, z is 0, so z dash. So this is x dash, y dash, z dash is a one term. Then go for the next one, put the addition operator. Next one is x is 0, so put x dash, y is 1, so put y, and z is 0, so write z dash. This is completion of second term. And next one at x equal to 1, so put x, and y is 0, put y dash, and z is 0, so put z dash, plus for the next one, so that is at x1, so put x, y is 1, so y, and z is 0, so z dash. And the last and final in f1, 1 at x equal to 1, y equal to 1, z equal to 1, so put x, y, z. In this way you got the function for f1. Similarly, you can find the function for f2, like f2 x comma y comma z equal to x dash y z dash plus x dash y z plus x y z. So these functions are also written in product of sum as follows: f1 3 variable x comma y comma z equal to x plus y plus z into x plus y dash plus z into x dash plus y plus z into x dash plus y dash plus z into x dash plus y dash plus z. This is the function for f1 that is given in table in the question. Similarly, we can find the function f2 in product of sum as f2 x comma y comma z equal to x plus y plus z dash into x plus y dash plus z into x plus y dash plus z dash into x dash plus y dash plus z dash. Now let us see logic gates. You can say that the collection of transistors and resistors that regulates the flow of electricity that determine the Boolean logic computer used to make complex logical decisions. The component of logic gates are transistor and resistor. There are three types of logic gates, namely AND, OR and NOT. These three gates are generally used in designing and developing the circuit. Let us start from AND logic gate. The AND logic gate is used to find the product of two or more variables. Let A, B and C are three variables which are written as A dot B dot C in the case of AND gate. The logical circuit of AND gate is given in the figure. So see, here is a circuit, the bulb. Here two key K1, K2 and E the power supply. If both the key is on, then bulb will be on. If K1 is off, K2 is on, bulb will not be on. If K2 is off, K1 is on, in that case bulb is not on. If both is on, then the bulb will be on. So according to this logic circuit, we can draw the truth table for AND gate. So two variable K1 and K2. So total combinations are 4, 0, 0, 0, 1, 1, 0, 1, 1. Means 0, 0, both the key are not open, closed, so bulb will not be on, so that is 0. If one key is open, that is 0, 0, 1, and next key is closed, so circuit will not be completed, so bulb will not on, so in that case is a 0. Another case, K1 is 1, K2 is 0, in that case circuit is not completed, so bulb will not be on, so it will be off, so you can write here 0. If both the key is 1 1 means both open, so circuit is completed, and that case bulb will be on, so 1. So this is the truth table for AND gate, and the symbol used here after the truth table is the symbol given here will use for AND gate. The state equation of AND gate is x equal to K1 dot K2 because bulb is on only when both keys K1, K2 are in the state of on. Now let us see OR logic gate. The OR gate is used to find the sum of two or more variables. Let us consider two variables A, B and C. These three variables can be written in OR gate A plus B plus C, and that is known as the OR gate. OR gate is used for summation. The logic circuit of OR gate is given here, means the two keys attached in a parallel K1 and K2. If both keys are open, then the bulb will be on. If any one key will open because it is in the parallel, so bulb will be on. Let us use this circuit to draw the truth table. So both key K1 and K2, all combinations here 0 0, 0 1, 1 0 and 1 1. In the case of 0 0, bulb will not on, that will be off, so 0. 0 1, in any cases bulb will be on, so you can write 1 here. In 1 0, bulb will be on, so you can write 1, and in the case of 1 1, then the result of course on, bulb will be on, so you can write 1. And after the truth table a symbol is given which is the symbol for OR gate, and this is used whenever required as a OR gate. Now NOT logic. The NOT logic gate is used to find the complements of a given input, means if input is 1, the output will be 0, and if input is 0, then output will be 1. Let consider A be the input and the output will be A dash. The logic circuit of NOT gate is given here. So in the circuit only one key is closed, off, bulb will not be on. If key is on, open, then bulb will be on. So it is the case of inverter. If light is coming, so inverter is off. If light has gone, then inverter will be on, and light come, inverter off. So if input is 0, then output will be 1. Input is 1, output will be 0. So 0 1 1 0, and the symbol used in designing the circuit that after the truth table is used. Next gate, that is the NAND gate. The NAND gate is the combination of AND gate and NOT gate. Let us see the circuit diagram of AND gate. In the bottom is the circuit of AND gate, and at the top circuit or NOT gate. These two gates are combined together. So the output of AND gate circuit will be the input for NOT gate, and NOT gate output will be the final output for the NAND gate. So the logical circuit diagram of NAND gate is given in this diagram. The logical diagram of AND gate and logical diagram of NOT gate are added to each other. the output of the logical circuit will be the input for logical circuit of NOT gate. The output of NOT gate will be the output of NAND gate. So, you can say AND plus NOT equal to NAND. Now, see here the truth table for NAND gate. First, consider two variable K1 and K2, write down all possible combinations. So, two variables have been the possible combinations 0 0, 0 1, 1 0, 1 1. So, the output of AND gate K3 equal to K1 dot K2. So, K1 is 0, K2 is 0. So, 0 dot 0 is equal to 0. So, K3 equal to K1 dot K2 will be 0. Another case, K1 is 0, K2 is 1. So, 0 dot 1 that is equal to 0. So, K3 equal to K1 dot K3 equal to 0. Now, consider the another case, K1 is equal to 1, K2 equal to 0. So, 1 dot 0 that is equal to 0. So, the value of K3 equal to K1 dot K3 is a 0. Another case, K1 is 1, K2 is 1. So, 1 dot 1 that is equal to 1, and then this K3 become the input for NOT gate. So, that is the output of NOT gate is the final result. So, X equal to a status of the bulb, 1 equal to on, 0 means off. So, K3, if K3 is 0, then the output will be 1. K3 is 0, then output will be 1. Here K3 is 0, then 1, and K3 is 1, then the finally output is 0. So, the symbol for NAND gate is used or shown on the screen on the right side of the truth table. The equation of NAND gate is equal to X equal to K1 dot K2 a whole complement. So, first find out the product of both the input and take the complement of the equations, then that equation will be the equation of NAND gate. Now, let us see NOR gate. This is the same as the NAND gate, only replace the AND gate from the NAND gate and add OR gate to NOT gate, it's become the NOR gate. So, the NOR gate is the combination of OR gate and NOT gate. The logical diagram, so the logical circuit diagram of NOR gate is given in the figure here. So, the bottom logical circuit of OR gate and on the top is the logical circuit of NOT gate. So, take the output of OR gate circuit and give the input for the NOT gate. So, that output of NOT gate will be the output of NOR gate. In this diagram, the logical diagram of OR gate and logical diagram of NOT gate are added to each other. The output of logical circuit will be the input for logical circuit of NOT gate. The output of NOT gate will be the output of NOR gate. Let us see here the truth table for NOR gate. First circuit given two variable K1 and K2. So, the all possible combination of K1 and K2 are 0 0, 0 1, 1 0 and 1 1. Now, put the value of K1 and K2 in the OR gate equation, and we know the OR gate equation if the variable is K1 and K2. So, K1 plus K2 is the equation for OR gate. So, the output of the OR gate will be the input for the NOT gate. So, 0 plus 0 equal to 0. 0 plus 1 is equal to 1. 1 plus 0 equal to 1, and 1 plus 1 is equal to 1. So now you got the output for the OR gate, and then give this input to the NOT gate, and you will get 0 here. So 0 complement of 0 is 1, and complement of 1 is 0, and complement of 1 is 0, complement of 1 is 0. So this is the truth table of NOR gate, and the symbol used in NOR gate are given here beside the truth table symbol. Simply add inverter to the OR gate to get the symbol for NOR gate, and the equations of NOR gate is x equal to x plus x to the whole power complement. So you will get the equation for NOR gate. Now let us see here exclusive OR gate. The exclusive OR gate produces output 1 or true when any one output is 0, false, and another input 1, true. If both inputs are same, then the output will be false, means output will be 0. Let two inputs are A and B, and output is X. The truth table is given in table. This gate is also known as XOR gate. The XOR or exclusive OR gate symbol is given on the next slide. So let us see this truth table A, B and X. So A, B are the two variable and X is the output. So combination of these two variable A and B are 0, 0, 0, 1, 1, 0 and 1, 1. And as per the concept, if both the input are same, the result is 0. So here A is 0, B is 0, both input are same, the result is 0. In another case, A is 0, B is 1, both input are not same, then the result is true. So you can write on the column of X is 1. Another case, A is 1, B is 0, means both input are not same, then the result will be 1. So here A is 1, B is 0, both input are not same, so finally the result is 1. And next consideration, A is 1, B is 1, both the inputs are 1, so finally the result is false, 0. So you can write 0. So this is the truth table, and the symbol given here on the right side of the truth table, and the equation of exclusive OR or XOR is given x equal to A plus in circle B. Now consider next exclusive NOR gate. Exclusive NOR gate is a combination of exclusive OR and NOT gate. The output of exclusive NOR gate will be true or 1 if both input will be either 0 or 1. The truth table of exclusive NOR gate is given in the table, and the symbol of exclusive NOR gate is given on the next slide. See here, truth table for the exclusive NOR gate. A, B are two variable, and all possible combinations of A and B are 0, 0, 0, 1, 1, 0, 1, 1. So X equal to A exclusive OR 0, both are same, so 0, 0, 1, both are not same, so 1. In the case of 1, 0, both are not same, then 1, and 1, 1, both are same, 0. So now find out the complement of X. So X is 0, then you can get 1. X is 1, take the complement, you can get the 0, so write 0 here. Again X value is 1, take complement, that will be 0, put 0 here, and the X value is 0. After taking the complement of 0, we can get 1, so write down 1. So the right side of this table, the symbol is used. The equation of exclusive NOR gate is given x equal to a dot in circle B. Now see here the circuit for Boolean function. The Boolean function is represented in the form of circuit by dot operator and gate plus operator with OR gate and negation with NOT gate. These fundamental gates used to convert the Boolean function into the logical circuit. Let us see one example to draw the logic circuit for the Boolean function. And the Boolean function is given here if x comma y comma z is equal to xy plus x dash y z plus y dash z. Now how can we draw the circuit for the functions? In this question there are three terms, first xy, next term x dash yz, and the third term x dash y. First draw the separate circuit for each term. So first one xy, so xy AND gate, so you get the term xy, and the next term x dash yz. So for the x dash yz represented by AND gate as follow: x take the NOT gate, so you will get the complement, so that is the x dash, take yz and use the AND gate to get x dash yz. In the third term y dash z, that is represented by AND gate as follow. So in here there is a y dash, to take y use NOT gate and output of NOT gate and y, so that will be the final result. Use the AND gate to y dash z. To get the final result, these all gates are added with one OR gate as shown below the figure to get the final result. Now consider another example. Draw logical circuit of Boolean function f x comma y comma z, that is equal to summation 2 comma 3 comma 4. To first convert the given function into the equation, so 2 can be written 0 1 0, 3 can be written 0 1 1, 4 can be written 1 0 0. So first convert it x y z equal to x dash y z dash plus x dash y z plus x y dash z. So again in this question three term, and draw the circuit for x dash y z dash, use NOT and AND gate. For x dash y z use NOT gate for x and simply add with the AND gate, and for x y dash z you can same and combine these all diagram together by using the NOT gate to add it to finally get the final result, that is the f. So the given function circuit on the screen is the result for the given Boolean function. So similarly you can also draw the circuit for product of sum 2 3 4 in the same way, just add will be converted to dot and dash will be deleted. So wherever x, then you can take the complement and dot into the plus. So in this way you can draw the circuit that is shown on the screen. So 2 is 0 1, here 3 variables, so 2 can be represented 0 1 0. So x means 0 plus 0 plus 1 into 0 plus 1 plus 1 and 1 plus 0 plus 0. So 0 means x, y plus 1 means z. In this way you can draw the given circuit. Thank you.
With this note, thank you, sir. Thank you so very much for giving us a precious session. And friends, for your feedbacks, you can just write to us at info.cec@nic.in. We will be meeting again and will be discussing on some new topic. Till then, take care. Goodbye. Thank you, sir.
Thank you, ma'am. Thank you.